Now, one important component of these functional groups that we often miss is if we look at carbon chain and then we put, say, a halogen here, so we can say, okay, well, this is a secondary alkyl halide. And that's fine, we can recognize that. But more importantly, we need to recognize that if we look at our periodic table, we know chlorine is more electronegative than carbon. And so as a result of that, we have a polar bond this way. And so this polarity is important when we look at infrared spectroscopy. It needs to be a polar bond. So this in organic chemistry is called electron rich. And this is our nucleophile or nucleophilic center. And this becomes electron poor, which is our electrophile. So bear in mind that when you're looking at molecules, you need this polarity to be identified or part of a molecule. So this is a polar bond, which makes the molecule polar. We look at something like a ketone. Okay? Anytime we have a carbonyl, we know oxygen's more electronegative, so there's a bond polarity here. If we look at something like a carboxylic acid, we should recognize not only do we have the polarity this way, but we also have the polarity this way. So this center is electrophilic. So please bear in mind that when you're looking at these molecules and identifying these functionalities, think back to your general chemistry, to something you learned in high school chemistry, no less, about electronegativity. Fluorine's the most electronegative. It just diminishes as we move to the left and down from fluorine. So look at our nitrile. Okay, bond is polar this way. We look at our triple bond. Okay, this is not polar. These carbons are equivalent. This is non-polar. So that's not just escape from the fact that, yeah, we've got differences in electronegativity, but we may have electronegativities the same. So a couple more examples. We got an ether. We got an alcohol. We know that oxygen's more electronegative, like so. We know oxygen's more electronegative, like so. And then finally, we've got our nitrogen centers. We know that nitrogen's more electronegative. So these carbons that are attached to nitrogens here are losing electrons because of that polarity. These carbons next to the oxygen, less electron rich because of this polarity. So please make sure you're aware of that. It's subtle but important when you look at a functional group to recognize these polarity differences, which is simply a function of electronegativity, to recognize that most compounds are polar covalent molecules. The only time we get nonpolar covalent molecules is if we have more atoms that are the same, such as in nitrogen or oxygen or bromine. Okay. Those are nonpolar bonds, nonpolar covalent bonds, because the atoms are the same in either. The nitrogen is electronegativity is the other nitrogen.